these multi-dimensional protocols where you need like 7 things to get right perfectly for one thing to work. The IBC and the consensus engine, and then our custom modules, and then the storage network, and then all the software for the storage providers, all working in harmony, and then we get one thing, just upload a file to work, right? It's just risky to begin with to build something so complex with so many different moving parts. It comes down to, we want to have sovereignty over the stack all the way down to the studs.
Welcome to the Bare Metal Podcast.
Hey everyone, thanks for tuning back into the Bare Metal Podcast. This is your trusty ship to code from Rockawakes Labs. Today here with Patrick Dunlop from Jackal Labs. Welcome.
Hey, thanks for having me. It's really great to be here.
So Jackal Labs, intriguing name. Take us through it. How did you get into Jackal Labs? What are you guys building?
Yeah, well, first and foremost, the name. So the name came about, like, we were looking at, we named it probably like in a 2-hour span. We were just like Googling different things, and we came across like Egyptian gods, and then we found out that there's this thing called the Anubis in Egypt that guards the tombs. We thought Anubis was a little bit of a mouthful, so we went with Jackal. So that's the name, first and foremost. But how we got into Jackal Labs, well, before this, myself and my
Wait a minute. Isn't Anubis a god of the dead or something?
Yeah, so it guards the tombs of Egypt.
Guards the tombs. I get that. Okay.
Yes, yeah. So we're just like, what if we had Anubis guarding your cloud environment? So that's kind of how we got into this, right? But so how did we get into this though? So myself and my co-founder, we were working in digital forensics investigations for law firms and corporations. We work with like e-discovery tools, and we work with like clean forensic environments, and that's kind of our background. We were trying to build like an e-discovery tool for court, and we realized pretty quickly that there's no real place in a cloud environment that you can have like self-custody and ownership and like a security posture that is like close enough to a clean forensic environment where only the end user with a private key can access their files. So that makes your life kind of lame when you're working in that field, because you have like all these hard drives that are stacking up on your desk, and then every hard drive has to have its own case and all these different things, and then you have all these virtual machines that are going around. So we were trying to like scratch our own need. We were just trying to build like an e-discovery tool for internal use. Then we found out that a lot of people were excited about the concept of having a blockchain as a data permission system. And then it kind of morphed into a DPIN network. So we started building on Polygon, then we were on the Secret network, and now we're our own proprietary L1 blockchain. So that's kind of our road to getting to this point. We started in 2021 November.
So what were the factors that led you guys to, build your own L1 as opposed to, deploy somewhere and connect some event listeners or relayers or something like that? Like why go for the, whole PSAS?
Yeah, it's a good question. So we make tech stack decisions based on risk, right? So if I look at, we work in risk frameworks, and as we get older, we try to de-risk certain aspects. It's like team risk and launch risk and hiring risk and then technical risk. When we were looking at where we wanted to build, when I look at like these decentralized virtual infrastructure networks or DPIN networks, depending on who you're talking to, they're these multi-dimensional protocols where you need like 7 things to get right perfectly for one thing to work. So we need like the IBC and the consensus engine, and then our custom modules, and then the storage network, and then all the software for the storage providers, all working in harmony, and then we get one thing, just upload a file to work, right? When you have all these different, it's just risky to begin with to build something so complex with so many different moving parts that we didn't want to add additional risk of having to rely on a third-party team to ship a protocol upgrade, or us beg them for a custom module for us to have the best product possible.
Right.
So it comes down to, we want to have sovereignty over the stack all the way down to the studs. And that allows us to build a more competitive product in our mind. And the reason why we kind of chose Cosmos as our L1 is we're not isolated at the same time, right? Because you can go and build like a monolithic storage L1, awesome, but if you're not able to integrate or have interoperability with other protocols, then you're kind of like fighting in a zero-sum game for developers and users with general purpose L1s, and that's kind of silly to us.
Was it difficult to spin up and find your initial set of operators, and get everything running? Because that's typically like the toughest part, I think, of launching the protocol.
I don't think finding the validators and kind of the storage providers, they just arrived out of nowhere. And we're not blockchain native team. Like, we started in a completely different field, and we just started in 2021. they just show up. I don't know how this works, but like the CapEx gets bootstrapped really quickly. The thing that I think was the hardest was working with the Cosmos SDK, and like there was the Ignite CLI, and then there's like the Cosmos SDK, and then there's like the Osmosis fork of the Cosmos SDK, and there's all these competing standards, and we don't know where the foot guns are in the different standards, and there's no leader or CEO of the Cosmos ecosystem that we can go talk to and say, hey, which one do we use, and who do we listen to, who do we not listen to, and that was the most difficult part. Is you're launching your protocol, you just kind of launching a blockchain in the Cosmos ecosystem is kind of like, did you ever play RuneScape growing up?
No, I haven't played RuneScape. I heard a lot about it though.
It's kind of like, I'm trying to think, when you deploy on Polygon or you deploy on like an EVM or Solana, you kind of like have like a tutorial, right? So you kind of just like, you show up and then you learn how to do all the things, and then eventually like you're released into the wild. Cosmos, you just spawn in the wild, right? You just show up, and then your blocks start producing, and then you just exist now out of nowhere.
Right.
So it's
The
a little bit
substrate
different.
is a Linux machine with like wide open possibilities. Green
Yeah,
just
it's
run.
just, and then there's all these people that just arrive out of nowhere. So yeah, it's interesting for sure.
Interesting. So you were talking about e-discover and forensics. Did you guys have use cases in mind? You mentioned like sort of custody for court proceedings.
Yeah.
That sounds pretty interesting. Like, can you sort of, I don't have that background. Can you dig into like why that's important? Why self-custody is important? I guess you are an expert witness, or
Yeah.
give us the setting.
So here's a situation that like we saw a lot where you have like two legal teams, like let's say that it's civil, for example, or let's actually go criminal. So you have the police, you have the defense legal team, and then you have like the bench, the judge, and all those people, right? What happens is that like you capture a piece of digital evidence, and the current state of digital evidence is like really bad right now because it's just like screenshots, and they bring a screenshot to court, and there's no verifiability behind it, and anyone can like make any photo exist, right? So there's a lot of like dirty evidence that are going through the courts. So the thing is that first and foremost, like anyone can alter it. So you need a way to have like chain of custody, number one, but also verify that the evidence is real in the time of capture and it hasn't changed since then. If you have like a proper analyst doing that. But the other thing is that you would create a piece of evidence, and then you would send it to the defense team, and the defense team would send it back, and then there's all these documents and analysts working on both teams that are sending files around, and then you get to court, and then you pull up a piece of evidence, but the metadata says it was made yesterday because there's copies of copies of copies, and we don't actually have the original piece of evidence. So having a way for proper track and trace of who had what data at what time is really important in this field. So our idea was, okay, what if we could build an e-discovery tool? We can put the blockchain the data permissions on blockchain rails, and then do like an integrated encryption scheme so you can still have privacy, things along those lines. And then we can create an e-discovery tool, and then we could go to the defense lawyers' conferences and just tell them that like, hey, anyone can create any file, and making sure that you have proper chain of custody, and if you don't use a tool similar to this, then it could in theory be thrown out of court. So that was the original idea. But then we realized...
I do remember, by the way, before blockchain, there were big companies doing this. Like it was write once, read many media. Like I think Fujitsu had a type of worm like that it was guaranteed to only be able, each byte would be writable only once.
Yeah.
But this, I guess, is much more open and much more transparent, right? Because that's a black box.
There's a lot of people that were doing it, but like back then it was just proof of work blockchains, and it was slow, and it was like kind of a little bit difficult for all kinds of different, and they were sharing block space with like NFT mints and all these different things, right? So there was nothing that kind of at the time that we saw that could have like proper permissions of who can access the data as well at the same time, because for you to deliver that as a SaaS product, yes, like you can like kind of bring your own drives and then kind of like have like the proofs work that way, by like kind of having it locally on everyone's machines. But we thought it's like, this would be awesome if it was just like a public cloud environment, but still had the security and self-custody where no one can access your data other than the analyst with their private keys. And we can do account abstraction and things like that, where we can kind of like make it a little bit better of a user experience. But that was the original idea. That was the original idea, is like, can you have like the world's highest digital privacy and cybersecurity posture in a cloud environment, where no one can access your data other than you, and if I wanted to access your cloud, I would have to like physically harm you and get your private keys. That was the original idea, but as we built it, we realized that there was no blockchain-based storage protocol that had permissions on chain. It was all marketplace based, or it was kind of like endowment based. So this was another thing that was interesting, where, wait a second, so all of the decentralized storage protocols, they don't have the ability for you to actually own anything, which is, I feel, is like a core principle, and like why all this technology exists in the first place, is sovereignty, self-custody. So can you create a cloud that is sovereign and self-custodial while still having the scalability that you're used to? That's kind of how.
How do you guys deliver this though? So I'm thinking through the construction. So I still have to custody my private keys to the data. That's on me, but you custody the bytes and make sure those are retrievable to people with the key. Is there like a system of keys that can access like a single piece of data?
Yeah, so everything comes down to your private key. So like, for example, what happens is we take your private key and then we encrypt the data using that private key. And then everything's encrypted locally on your machine before it gets sent to our storage providers. So we have two peer-to-peer networks. One peer-to-peer network of storage providers, and then we have another peer-to-peer network, which is just like Cosmos SDK validators, basically, right? And how would I explain this? The validators are like the police of the network, where they make sure that all the data is being stored. They make sure that who has access to what data, what time, and then it has a bunch of other things.
And they keep the ledger of the transaction, I guess, right? Who stored what where?
Who stored what where, all that stuff. So that's like one piece. And then we have like our proof of persistence and detection of loss protocols with the validator set. The storage providers, they do one job basically. So they store data and then they submit proofs to the protocol that they continuously store the data throughout the duration of the storage that's purchased. So that's kind of how that system works. The storage providers are interesting in the sense that, and then we had to get into a bunch of scalability stuff, because originally, like the original model is like we would take 1 kilobyte chunks of the encrypted files and submit that to the validators, and then they would have to like yes, no, that file is continuously being stored. We had a moment where like our blocks were like so full, and we had the situation where we actually had to do off-chain kind of consensus between the storage providers themselves. So the storage providers would come to, we call them consensus spheres, where they would prove cryptographic chunks to each other, and then they submit attestations to the chain. Right. So that's kind of how, and then we got into like string compression for scalability. But our blockchain has the most transactions in the Cosmos ecosystem. We'll say that for at least. But that's kind of how that works in general. Is storage providers submit attestations to the chain that they continuously store the files. The validator set makes sure the files are stored by kind of creating and burning storage deals to maintain redundancy, that the file is continuously being stored throughout the duration.
So validator set would like create a challenge, and then the storage provider would have to sort of solve the challenge that involves like knowing some piece of data. Is that a fair mental model?
Yeah, so every individual file will have 12 hours, like it'll come to its moment that it has to be proved that it's on the network. So every 12 hours, each individual file will be proved. And that's kind of how we do that operation. And then what happens is it has this challenge, a bunch of storage providers show up, and then they actually have to send 1 kilobyte cryptographic chunks to each of the other providers in the consensus sphere, and then they kind of come to consensus there, and then they'll submit the attestation to the chain.
Right.
So that's how we operate that in general. It took us a while to get to that point, though.
So what are the, this is a high assurance product with, built for sort of like the level of, let's say, paper trail and auditability that's required by paper trail, digital trail, and auditability required by some courts, right? So like who is the user today? I mean, does anybody leverage these features? Is it important for the current users that you guys built all this in?
Yeah, so we've abandoned the whole digital forensics tooling. Like we shelved it. It's sitting there. We're waiting for the data that comes back. But the wallet UX isn't there for a product like that right now. let's just, if you want like the full self-custody and ownership aspect of it, we would have to kind of introduce like centralized choke points of failure, which then kind of begs the question of like, okay, what's the point, right? So right now, like when we're looking at we built this public cloud environment, it's like ridiculously secure, has like a super high digital privacy posture, and it's verifiable geo-distributed storage that auto heals. If a provider misses a approving window, if they miss 2 in a row, that file deal gets burned by the validators. They send out a new one, and then they copies from the forms of redundancy. So you have like this whack-a-mole storage that's public cloud, right? What do we want to do with it? Yeah, it's literally whack-a-mole backups where they just auto-heal and they pop up on the other side of the world out of nowhere. So we have the system. We have 2 types of users. So we have about like 1,000 individual users right now that use it like a Dropbox. That's privacy and security advocates, and they love it for what they use it for. When we look at kind of, if we want this to work, we need to move data like petabyte scale eventually, and that's where we need to go. So we have 2 types of users. User number 1 is like other general purpose L1s where we deploy smart contracts there. We use cross-chain messaging, so we get like packets back to the protocol to do actions on behalf of the users on those chains. That's use case number 1, where we just deliver tooling to other developers and users at the smart contract level, so you can like bake it into your protocol, which is pretty fun at that point, where you can like build things where, for example, when we go to deploy an outpost on Stargaze, which is like an NFT-based L1, we can actually bake it into the protocol so that all the JPEGs could even be paid for on transaction fees. To make sure that it continuously gets stored rather than introducing the centralized choke point. Obviously, like the CDN is going to have to kind of still be living on like a Microsoft Azure environment for now until IPFS, like we also have IPFS support coming in V4, but it's interesting for that use case. So it's developers and users that value decentralization, self-custody, interoperability, all those different things that we love in blockchain space. Web 2 users don't care about any of that, right? So what they care about right now is they're able to get geo-distributed verifiable backups for their organization's data. That's 200% cheaper than what they're seeing with like AWS. If you want to have like multi-region redundant backups. And
so like a third of the cost, let's say.
It's like, well, when you factor in the egress and ingress, we can't charge for that. Right. So the majority of the budget, like when you have like 3x multi-region, like you throw up one file on an AWS server and then it has to copy to the 2 other servers and they copy between each other back and forth every time the data changes. So your storage can balloon to like $200 a month per terabyte of data being stored with like that. If you want like one region in Asia and another region in UK and maybe one in the United States. So it gets pretty crazy pretty quick. So for that use case, it's pretty awesome. For just kind of something as simple as data backups for a use case like that.
So are we talking about like smaller companies or mid-sized companies, sort of like where they'll have their own IT department who go like, I'm looking for a cheap like off-chain off-premise safe backups, and then they find you guys somehow. How do they find you?
Our ideal customer profile is like someone that recently got like promoted to like a management position, but they're also like a secret like blockchain degen on the side. That's like our bread and butter right there. So for example, like we were able to land like an Iowa telecom company, which was cool. So like they're backing up all their user data to Jackal, which is just an awesome use case to begin with. They use like API connection, so it's not like they don't self-custody. It's kind of like more like it's just like the centralized exchange version of Jackal, basically, where like we custody the keys. We just they pay with Visa, and then they get the value of multi-region verifiable geo-distributed backups, right? So that's like one
but
example.
that's legit, right? That's the way to connect to many existing sort of customer bases, which is just not interested in the keys, but they'll have like there could be 3 providers like you, right? With all having a backend on the Jackal chain. And they could just make a deal with 2, so they have distribution on the keys in case company goes out of business.
Well, and the other thing is that they don't actually have to. The cool thing about Jackal is like it's all baked into the protocol. So like they don't have to manage storage deals themselves. They don't have to manage encryption keys themselves. They don't have to do any of that. They just pay the protocol, and the protocol sets the price as well. So it's not going to change all the time. So it's like right now it's $8 a month per terabyte with 3x redundancy. and you purchase that, and then the protocol just takes care of it for you, which is beautiful in its own right. So for like a use case like that, it's awesome. So that's only going to be organizations that like kind of do on-prem servers, and they have backups. What we're working on right now, and we're starting to flirt with the idea of, is kind of like, we were talking with telecom companies, and we were talking with lawyers, and we were talking with all these different industries in general, and then that kind of led us to like managed service providers, which is like an interesting kind of little niche where, like, you say you have a law firm, you're not going to hire your own tech team, you're going to outsource that to a third party. Something interesting going on in that region right now is there was Cassia, I think is the company. They rolled up like all the MSP provider software for like Microsoft 365 backups or Google Cloud backups or like ticketing systems and database backups and all those like basic things that MSP providers are supposed to provide to their clients. We were looking at that where if we're able to like do cloud to cloud, like mailbox, like charge by the mailbox and like back up all that stuff. The beautiful thing about blockchain technology is that the OpEx is completely bootstrapped. The OpEx is automated into the chain. The CapEx is completely bootstrapped. So like we're able to provide a service that has a bunch of features that don't exist previously, and our pricing power is really extreme. Like you're looking at like $5 to $8 a month per mailbox. Like we can make profit at like less than $1 a month per mailbox, which is pretty crazy if you start to think about it on that front. It helps us jump the moat of like if I wanted to compete head to head with like protocols like that, or just like products like that, you have to have like $1 bajillion to spin up all these data centers. You have to like start to like hire a bunch of people. When you have blockchain technology, you can like jump the CapEx moat really quickly, and if you can build a product that has features and delivers value that isn't previously or currently seen in that industry at all, you have a unique opportunity to actually kind of shake it up a little bit, which is kind of interesting. And that's what I love about this technology is you can bootstrap huge networks of computers and services really fast, and you can increase security and privacy posture, all that good stuff.
I'm curious, do you know off the top of your head what's the storage capacity on Jackal, or even the used storage right now, like just as a ballpark?
I think our utilization ratio is 19%.
19%.
Yeah, so this is something that when you look at kind of the current storage L1s, and like we were trying to figure out, like, okay, like why has this not been a thing? Like why has no one really used these protocols in general, right? You look at like Arweave, like they only have, I think it's 109, their weave size 190 terabytes. They've been around for a long time, right? You look at storage, or you look at Siacoin, it's still like they're not at the scale that you would expect these protocols to be at, like if they started back in 2018, 2017. So we're trying to figure out, like, okay, like why does this not work? And I think weirdly it comes down to tokenomics, which is like kind of a weird thing where you're bootstrapping these networks and you want like all this capacity to come online, and then you find yourself overpaying for capacity, and then you're starting to you actually can't get data to come on the system. So now you're like incentivizing or subsidizing the cost of storage on like Filecoin, for example. So now they're giving away storage for free. And then you have this system where it's like highly inflationary, and the market cap stays the same, but the token price goes down only. And it's really hard for you to incentivize new providers to come online because you have way more capacity than you have actual utilization. So we actually moved to real yield, which is interesting. So we're trying to like actually get really close and close the gap between actually having the perfect amount of capacity for the storage that's demanded. So right now, I think last time I checked, we were approaching like 1 to 2 petabytes of storage capacity. Storage purchased was around 300 terabytes. And then storage used, I think it's like approaching a terabyte right now. But for a long time, the protocol was unstable, and we're getting to a place now where it's actually actually starting to get scalable, which is interesting too.
300 TB purchase, so we didn't really dig into the commercial model, but I guess you were like, I gather I have to rent the space. I have to subscribe to the space, and then that space is reserved for me. I can use it.
Yeah, commercial model is basically you have like one wallet, or sometimes we multi-thread it because you can only do like one file per 6 seconds, because like you can't like sign deals from multiple, so you have to like have a bunch of different wallets that are all pushing files to the network at the same time through that route. So you'll have a bunch of wallets that have storage accounts, and then the commercial model is we take Visa, they pay Stripe, and then we have to buy back the tokens to pay the provider, protocol and the providers on the protocol that way. On the protocol level, like that model is you just show up with Jackal tokens to the protocol. It's $8 a month per terabyte. It's like a prepaid storage plan. Say I want like 2 years of storage, or 10 years, or 200 years of storage. You can purchase there until we get like streaming payments. That's the only way that we could do it from that level. And then for MSP providers, if we want to go down that route, so you traditionally charge by mailbox, which is interesting. But when you look at like the protocol and the relationship between the protocol and the applications that are built on the protocol, the applications usually just take the margin between the cost of storage and then how much the customers are willing to pay for that specific service.
When you say real yield, does that mean you guys are trying to push the inflation to zero, or have you actually zeroed it out and just like, distribute the income, the revenue from the actual customers who are buying the storage among, into like a treasury that then distributes to the operators, to the storage providers?
So literally this week on Friday, like our Econ V2 is being pushed out, and that'll be on chain. If anyone wants to go look at that and vote on that, it would be really exciting. But essentially what we want to do is like we want to push it to zero, and we want to get real yield working, because we think that this is like a perfect use case. It's just a multi-sided market, and having inflation for that is great for bootstrapping. It's great for getting to a point where you have enough supply side. But if you have all the supply side, there's no point in pushing the supply side more if you don't have the demand side there. Yeah. So we want to get it to zero, but the way that we're looking at it right now is we're going to have like a storage stipend. So like you kind of think about it like it's universal basic income for storage providers, assuming that we're not able to drum up the demand side. Like they can get like a basic payment of X dollars relative to how much storage they actually provide to the network. That has to be foundation based, because there's actually no way of the protocol knowing how much storage is being provided by that machine. So that has to have a little bit of a human intervention, but we want everything else to be real yield, and we want to wean off of that if possible eventually. But that's the model that we're going with right now. We just want a healthy economy at the end of the day, right? It's and then the validators, obviously, like there is inflation for the validators, but we've lowered it from like it was at like 25 or 28% down to something that's a little bit more sustainable.
And looking into the future, 4 or 5 years from now, like where's Jackal? Is this use case exploding? Are you guys trying to look at other use cases? Like, will you be more horizontal, looking at other groups, or just like digging deeper in the direction you guys are already going?
It's a really good question. So it's weird when you're building a kind of a protocol like this, because you have two very different customers, right? If we want to get a lot of data, we have to kind of go to Web 2, right? Because that's where all like really large files, because blockchains are good at a lot of things and they suck at storage. So all of these applications they don't spin off a lot of data every day. So we can do things like storing chain state and backups, and we can provide JPEG storage to NFT marketplaces. And there's the first thing that we want to do is we want to like own our backyard of blockchain technology. So our end game in blockchain world is to make sure that everyone on any chain can access Jackal with a smart contract call locally. That's really important to us. And then we're able to use message passing through IBC, or we can use like Axelar GMP or a hyperlane, maybe depending on who wins like that interoperability race. So we want to deploy like interchain accounts controller contracts onto every general purpose L1 and some app chains that make a lot of data, like SwordChain or Stargaze, for example. Mm-hmm. Have all the developer tooling there so people can build web scale applications on chain with like just storage natively with a simple smart contract call. Second thing, we want to find like the killer app for Jackal. And an app that would be valued, like this is probably a bad example, but I want to say like what is like the anchor protocol of the Jackal protocol? Like what's that killer use case that's going to drive demand to get data onto the system? Is that going to be a blockchain native application? Is that going to be Microsoft 365 backups for mailboxes? Is it going to
Google
be
Takeout.
Google Take? Like what is it going to be, right? So trying to figure out what is the killer app that's going to drive the majority of the data coming onto the system. That's what our search is right now, and that's what we're focusing on right now. So we've been building since November 2021. Obviously, we started on Polygon, then we're on Secret for a hot set stint, and now we're on L1. So there's been a lot of development work, but we're finally getting to a place where we can actually breathe and we can look at the landscape and make decisions on what our next move is going to be from the development front, which is interesting in general.
Well, fingers crossed all that works for you guys. So that sounds like a great place to end the recording. So thanks very much for
No, I appreciate it.
and explaining everything about Jackal.